Thank you, Philip, for joining us today. How you doing?
Indeed, I'm doing all right.
So I'm going to put you on the spot the same way that Layla put me on the spot, which is now
Okay.
you get your chance to introduce yourself to the amazing folks watching around the world.
Yeah, sure. I always feel weird introducing myself. Um, I'm Philip Carter. I currently work for a very cool startup called Honeycomb. Fun fact, my VP product and manager used to be head of product over at Auth0 as well. Auth0 has a good developer experience overall, I think, especially compared to some others. You know, uh, good vibes all around. On the Honeycomb side, we're also similarly, we're much earlier stage than Auth0, but focusing on trying to build really good developer experiences and stuff like that. So that's what I do right now. And it's entirely unrelated to F Sharp. I mean, like there's a little bit because there's a focus a lot on the Open Telemetry project, and there's OpenTelemetry.net, and there are F Sharp users who use Open Telemetry. It's a couple degrees removed from the F Sharp language itself. Prior to Honeycomb, I spent about 6 years at Microsoft working on the .NET team the entire time. And 5 of those years I spent doing a significant amount of my work with the F Sharp language and tools for Visual Studio. So I kind of covered the breadth. I was there for the push to .NET Core 1.0 and the subsequent releases, and pivoting over to .NET 5 and kind of changing messaging and all that, and kind of making this, instead of these two parallel tracks for .NET, making it like modern .NET and the other stuff. A little shy to say the word legacy, but since I don't work for Microsoft anymore, the legacy stuff. Was able to do a lot of really good things that I'm pretty proud of. Take an entire language and lift it from only being available on Windows to being available anywhere. And in some cases, having a better experience for certain things in non-Windows environments. And that's a total shift, I think, from kind of the traditional meme that F Sharp was OCaml for Windows. And that's just kind of like one small case of the general .NET story itself. So,
Well, I had to put this up on screen. Legacy equal legendary. Let's never forget it.
Indeed. Oh, it's legacy in that there are some wines out there that are like a legacy vintage that are so tasty. I guess I don't know. I'm not a wine drinker, so.
I hear you, man. Well, you sound like you've got quite a breadth of experience, but also are like the go-to. Like I feel like you should now become like the person I go to for all things F Sharp. I'm excited about this talk, actually.
You can still do that. I'm still on the board for the F Sharp Software Foundation, and I do spend a good amount of my time when I'm not in work hours doing F Sharp related things, like in the community, answering questions in Stack Overflow, doing some open source maintenance and some F Sharp projects that people rely on, things like that.
Well, I gotta say, I mean, I've had a chance to sort of get a sneak peek of some of what we're going to be talking about today, but I want to sort of start at like the fundamental basic level. Like, I don't know how many folks who are watching like have exposure to F Sharp. So just like, how would you describe F Sharp? Like, what's a scenario where someone would like learn about F Sharp or learn to write with F Sharp and would want to use F Sharp?
So, there's kind of some of the F Sharp community that, let me back up for a moment. Every once in a while, someone kind of asks, like on Twitter or something like that, "Oh, what's F Sharp for?" And then people in the community will say, "Oh, it's for programming." And it's like, okay, well, that kind of answers and doesn't answer the question, because it answers it in the sense that like it's a general purpose programming language.
Right.
Pretty much anything, for the most part, that you would use C# for, you can use F Sharp for. Same thing for like Java or Python or something like that. But it does shine in a couple of areas, I think. First, choice of language is kind of like a preference thing. As much as some C# developers like to rag on Java for being overly verbose compared to some of the nice stuff that we have in C#, some Java developers actually do prefer that. And they look at some of the newer things coming along, they get kind of freaked out by that. then there's there's people who look at like C# and they go, God, that's so verbose compared to like Python, for example.
Right.
And on the other end, there's C# developers who could look at Python and be like, what the hell? Like white space sensitivity and like all these like weird snake case and like some things lowercase, some things not lowercase. Why are these colons here? Like it's weird.
Yep.
And so F#, I think, kind of finds its place a little bit more along the folks who look at Python and say, oh, that's kind of nice.
Interesting.
It's not like Python for .NET. It's a very different language. It has a heritage based out of functional programming, not out of kind of smorgasbord programming that Python does. And it's statically typed instead of dynamic. It uses type inference, which is a really cool thing, where the compiler is able to figure out what the types of things actually are at compile time based off of how you're using them. And so it allows you to write really succinct code instead of having to declare, like your public static void main string thing args or whatever. You can just have a function called let main, and then it's able to figure out sort of what the types are based on how you're using things. So I think like at the end of the day, it's best for people who like succinctness in their programming, but they want to stay on .NET or they want to utilize some of the awesomeness that's in the .NET ecosystem. And integrate with platforms, be able to use like, first-class SDKs for Azure or AWS or pretty much any service out there that has like a standard .NET SDK or just small library bindings even. You can use that from F# with pretty much zero problems whatsoever. Delves in the details. Sometimes some things can be a little bit awkward, but things are always awkward in programming anyways. So there's nothing perfect in the world.
Well, and I love this piece of feedback here where our friend Nick has said, I've never used F#. I'm actually impressed and fascinated on functional programming. Always wanted to learn more about it.
Yeah. It's also, so that's actually kind of how I got my start with the language. I was tasked with writing this enormous code base that had like a big old WinForms app, and inside of the WinForms app, there was like, oh, well, we need to have a DSL in there for like these power users. They're the thing that are doing something with it. And I was like, well, I've never written a DSL before. So I just Googled how to write a DSL in C#. And I got like somewhere in like the third or fourth result or something, it was like, you should use F# to write a DSL instead of C#. And I was like, huh, interesting. I'd seen F# in like the new project file dialog before, and I think I even created it once, but didn't really think much of it and kind of moved on. Mm-hmm. And so I clicked on it just because I was curious, and it was like, hey, here's like some reasons why kind of the principles of functional programming or functional first programming, I guess, can apply themselves really well to writing a DSL and an interpreter for that DSL. So I was like, hey, I've never done this before, so I don't really have much of an opinion. If this says that it's a good choice, I'll give it a shot. Let's try it for like a couple days and see if it sticks. If I don't like it, then I'll just go back to C#. If I do, then I don't know, we'll figure out what we do from there. And I totally loved it. And it kind of fit really well because there's just kind of this style of programming that's about decoupling your representation of your data from the functionality that operates on that data. Mm-hmm. Have that data be immutable rather than kind of change with respect to some conditions that are going on in your program, and such that like it's not about changing the data itself, it's about transforming the data into another shape and sort of building out kind of this like pipeline of functionality where you transform data at different stages based off of certain rules. And the language just had it felt like it had the right tools for me to use at the right time when I was building that kind of functional pipeline of, okay, here's like this raw string that has like these commands. Each of these commands represent like cases of kind of like a grammar that the DSL represents, and then kind of going from there. And then once I sort of had this nice, tight domain for what the language actually was, operating on that and doing the correct transformations at different stages was really, really nice. And one thing that I loved was the compiler was a tool in this case. You sort of end up in this spot when you're writing functional code with F# where you use what are called discriminated union types, where you sort of represent, the data could be of one shape or another shape or another shape or another shape, and then the compiler forces you to account for every single one of those shapes whenever you're operating on that data. So if you miss one, or if you miss one, then like the compiler will be like, "Hey, buddy, you're missing this thing." And where that really comes in handy is error cases in particular can stop being like exceptional. Like, yeah, you're still going to have some exceptions. Sometimes exception handling is actually the right thing to do in F sharp, and that's great. Exceptions work well in .NET. But if like an error in your processing or an error in like how somebody does something can be lifted up into your domain, then you can take that and you can represent it in the F sharp type system. And now the compiler knows about all those error cases and forces you to account for them. Now, from there, you still have to account for it. So like if you write bad code or, whatever for dealing with those error cases, then, it's still not, it's not like a magic silver bullet or anything in that regard. But it's amazing how easy it is to think about the ways that something could go wrong, lift that in a very succinct way into your code base, so that it's just a single line of code represents each error case, and then you see your warning list in Visual Studio blow up, and it says, "Hey, guess what? You have not accounted for all of these cases in all of these places," and you just go one by one, fix it up, and it's super, super productive. I really love it. Yeah.
I was just going to jump in real quick. I know we've got some fun stuff you want to share as well. I just saw this comment come in. I just want to make sure we get this up on screen. It says, "I love functional programming. It typically avoids mutable state and can lead to cleaner, concise code that is much less error prone." And I think that's closer to some of the stuff that we're talking about here as well.
Yeah, I completely agree with that. It's when you're immutable first in everything that you do, it forces you, like, you can't cheat, right? Like, and it's not that being mutable is cheating, right? Like there's a lot of scenarios, especially when performance is concerned, where you have to be mutable because that's how computers work. But like when you're in kind of like the business logic space, sometimes it's just so convenient to just like, I'm just gonna make this a variable here and just kind of set it and forget about it. But then like that method grows over time, and sooner or later you've got like a really big long method that's kind of hard to extract logic out of, and now it's like somebody new comes onto the team because you left and you're doing something else. They have no clue what's going on, and there's a little subtle bug in there somewhere embedded in like some for loops and if statements and stuff like that, and like that's hard. But if you work in a system where you can't just change the thing because it's convenient, it forces you to structure your program in a way so that everything flows kind of cleanly from top to bottom. And that is, you can turn that off in F sharp. You can declare something is mutable, but like it's explicit now rather than everything implicitly being changeable at all times, which is, I think that gets to that comment. And that's something why a lot of F sharp programmers love using it, especially for more complicated systems where, they don't want to be debugging stuff all the time.
Man, I gotta tell you, I'm like, you've convinced the C# developer in me to be incredibly curious about F#, and I know we're here to talk about F# in the enterprise. Are you ready for me to bring in your screen here?
Yeah, let's do it.
Let's do it. Let's see where we're going here and go have a little bit of fun.
All right, yeah. So this is the part where I go through some slides. I'll try not to bore people too much. There is some important content on here though, so I want to make sure that it's there. People can take screenshots or draft it down, something like that. So what I would say is just F# in a nutshell, right? If I could boil it down to just this, it's for writing succinct, robust, and performant code, right? It looks kind of like Python, but it's not Python, it's still a little different, but it runs on .NET. So you get NuGet, you get Visual Studio, you get JetBrains Rider, you get Visual Studio Code, you get like all of these things that you expect as a .NET developer. But you can use F# in a language that looks a little bit more Pythonic, right? So like on one side here, I have a bit of code. There's a little bit of stuff that's alighted to wire up to ASP.NET Core, but like this is the left right there is actually a web server in F#.
Wait, I'm confused.
Right, you have two routes. One is the ping route, and the other is just empty. In fact, I could probably bring my cursor on here. It's a little small, but you can see the green. The ping route composes. This is just a little operator that you can use. the library there, and then text, it just says the word Pong. And then the route right there, it creates this one where, you don't, it's just the empty route.
Yeah.
You just create an HTML file. This is, again, something that comes from the Giraffe library. And then you have an HTML file and you just serve it up. And then,
Wow.
if you're a .NET developer, you can see, oh, there's iApplication Builder, iService Collection. You're just kind of wiring it up into the ASP.NET Core platform. This is actually, I think, some .NET 5 code and .NET 6. It's actually even more succinct because of the minimal API work that went into .NET 6. I believe you literally just add a single line of code called add giraffe or use giraffe. And then, because giraffe is the name of the library. And then this thing called web app, I think you register it as, your web app. Like I guess I should have updated the screenshot there, but hey, .NET 6 is kind of new. So
I'm just blown away by what I'm looking at right now. I'm like, wait, what?
yeah. And so actually, the minimal web API stuff, it didn't all come from F#, but like the team looked at some of the stuff the community was doing in the F# language, and they're like, hey, this is actually really good.
Yes.
We shouldn't necessarily create the same thing because different languages are different and so forth. But like the 3 lines of code to define 2 API routes, like we should be able to do that as well, and we should make some of this boilerplate here a little bit better. And so that's kind of what that's all about. And then on the right hand side, this is kind of like some data processing code that you could do. You got like this thing called a slice map. It's not in the F# core library. It's actually from like a numerical processing library, and you have like a list. You have like this thing called like a list expression. I'll kind of talk about this later and show it in some code, but you can sort of very succinctly programmatically generate data in the same way that you do in Python, actually. But in this case, it's an F#. You can index it. You can kind of make it 2-dimensional and so forth. And like key thing is it's succinct code. But the thing that's different, if you compare this with Python, it's all type checked. Right? It's all this is all .NET types that you're seeing here. This is stuff that runs on .NET. It compiles, so you can't just like write a bunch of garbage here and expect the compiler to accept it. And it's going to run fast because .NET is really, really fast, right? Wow. So you just don't have to really think about it that much. So that's
I'm blown
what
away.
I'll say. It's like in a nutshell. There's a whole lot more to the language, but if I could just distill it down to what you have in a single slide. This is sort of the key takeaway that I would want people to have. And like everything, like if this is compelling to you, then I will happily continue. If you look at this and you're like, it's not for me, then this is the time to tune out, I guess, because we're going to get a little deeper, I guess.
No, stay here because I'm super curious to see the code. Let's keep going.
Yeah. All right. So if you're using F#, right? Number one, it's really awesome on the server. Okay. Most F# programmers use it on the server with .NET 6 or .NET 5 or so forth. There's 3 major libraries that I know of right now that bind to the ASP.NET Core middleware system. Giraffe is actually this code right here. This is Open Giraffe. It's kind of more of a low-level one. There is a framework called Saturn that uses Giraffe under the covers, which uses ASP.NET Core, and it kind of has like a bit more of a higher level abstraction kind of way that you define stuff. And then Falco is kind of like a different alternative. You could look at all 3, but these are the 3 that I would encourage you to check out. They all have a slightly different take on how you model your routes running on ASP.NET Core. You kind of pick which one you like most, and you go from there. And it's got full access to the modern .NET ecosystem. So anything that you could do with .NET on the server, you do with F# on the server. And so because of that, that's why most F# programmers are doing that today. That's just kind of how it works there. But F# is also a JavaScript language. Now, I didn't mention this before. I kept talking about .NET, and this is the .NET Beyond conference. Why am I talking about a JavaScript language? Well, that's because the community is really awesome. Okay. So there is a transpiler called Fable built by the community that allows you to transpile the F# language into JavaScript.
No way.
And, there's kind of like an application architecture. It's called the Model View Update architecture. If you've been following along with some of the .NET MAUI stuff, they're trying to have a similar kind of MVU style way that you build your UIs programmatically rather than kind of split between like XAML markup and code that executes on that. It's also very similar to like Jetpack Compose or Swift UI. is kind of the way that I'd sort of sell it there.
Oh
But
my goodness.
critically, it's a JavaScript language, right? So like you're not using NuGet anymore. You pull in npm packages. And so what that means is there's a couple of, just like I'd say about 5 or 10 things in the F# core library that are unavailable to you because of that, because they're
Right.
about like dealing with .NET specific stuff.
Right.
But everything else is fully transpiled. And so the community's even built a project called the Safe Stack. Safe stands for Saturn or whatever. A is Azure or AWS if you prefer. F is Fable, and E is Elmish. Elmish is the name of the library that does this model view update thing. And so it's
Wow.
like combine these 4 things that are disparate together, and you have kind of like full stack application that's fully F#, F# on the server running on .NET, and F# on the client running on the JavaScript runtime.
Philip, I'm going to jump in real quick. We've got fans of Safe in the chat today. Layla has said, "This is why I persisted with Safe. It's awesome." I also saw another person say, "I was very impressed when I tried Safe as well." So clearly I'm out of the loop. I need to catch up, but
Yes.
this sounds amazing.
You should totally try it. And just keep in mind, Safe is not the scaled agile framework, Safe 5. That absolute trash fire. It is something much, much better. So then there's another alternative called WebSharper that's been around actually a bit longer. It does a similar kind of like transpiling sort of model, but different takes entirely. I would say it's kind of more like on the enterprise grade, right? So like Fable and this kind of stuff, it's like you assemble your toolkit and then you build your app from there. WebSharper is like, hey, we've assembled a toolkit, built a full enterprise grade kind of like full stack environment for you, and you can build your applications there. And so like it's the kind of traditional, like you can buy a license, you can get a support policy with that, all that kind of stuff. And you can build full stack web apps much in the same way where you have F# code running on the client and F# code running on the server. On the client, it's JavaScript, and on the server, it's .NET. It's also really good for data analysis. Okay, we're getting an increasing number of people actually coming over from Python using Jupyter notebooks and saying, well, F# kind of has the goodness that I like from Python, but I want more static types. I want a bit more safety, and I want a bit more performance. And so one of the key differentiators that we have there is it's trivial for including packages. So you notice on the right-hand side there's this little bit of syntax called #R NuGet : newtonsoft.json, open newtonsoft.json. Mm-hmm. That pulls in the JSON.NET library that you can immediately use in the same cell of code and execute. So, you can see kind of in the output there, it said installed package newtonsoft.json 12.0.3. At the time, I think it's a higher version now. And it's serialized an F# anonymous record just as a JSON object. And like right there, 4 lines of code, I pull in a JSON parsing library and I can serialize JSON code. In the Python world, if you want to do this, there's like 4 or 5 different ways to like do this, and there are like various foot guns involved depending on what you want to do. You got to either create a virtual environment or a pip environment or an Anaconda environment, or you need to like shell out to a pip inside of your notebook in a very specialized way so it doesn't screw up like your system-wide install of stuff like that. Mm-hmm. That's just way too complicated. Yes. And after you just plug in a single line of code that says give me the package, and then you're good to go.
I love this question that's just popped up that says, did Philip just imply that F# is better performing than Python?
Indeed, it is. That owes mostly to .NET, of course. .NET is very focused on performance, and yes. I mean, not that Python is terrible. You can use it; it works fine. A lot of enterprise people use Python, and it works great for them. But .NET runs a little better. So that's just my opinion, I guess.
I love this though.
So, kind of a case study. I realize now I should have included a friggin' link to this. But the COVID tracker used by Slovenia is actually all written in F# for the web in Java. F# compiled to JavaScript. So I pulled this screenshot on the right-hand side from the GitHub repository. Notice it's almost 80% F# code. In fact, F# powers all of the visualizations which make up the bulk of the application. So like this graph, it's like a fully interactive graph that shows, what the COVID situation. There's all kinds of other visualizations that they have. All of it is built in F# because it's the most complicated part of the application. And so they actually model the domain of what all these things are as F# code, and then they operate on it. And then it just runs in a Vue.js app on the front end, and it just talks to like some APIs via like fetch, basically.
Oh, that's amazing. This is phenomenal. I'm definitely shout out to our friends over at VMware and Layla behind the scenes, dropping the link just directly there in chat. If folks are interested, they can go have a look as well as a link to the F# language documentation, which is phenomenal. I know they've got some tutorials out there on the Microsoft site, but I'm sitting back watching this and I'm like, wow, this is phenomenal.
Right. So like, if you want to build an application that runs on the web in F#, like you can build something that looks like this, and it's going to take a little effort, of course, but
yes,
especially if you're learning it for the first time. But not only is it entirely possible, but it's something that can be used by an entire state, a sovereign state. So that's pretty cool. Okay, so I now want to talk a little bit about F# in the wild before I show some code, because I think it's important to cover some of like the history and understanding of like, okay, F# in the enterprise. Well, where was it actually used? What's some examples of what people have done that I know about? So, I spent 5 years talking with a lot of enterprise F# developers and learning a lot. And, there's some pretty cool stuff there. So kind of as a brief history on recent F# stuff that's been going on. So in 2017, with .NET Core 1.0, F# 4.1 released, and kind of the big theme there was .NET Core support. And there were a bunch of like smaller language features. I won't really dig into it, but that was sort of the big thing: cross-platform open source. F# was actually open source prior to that, but we'll just kind of say the two things in tandem. Then there was a bit of a stint in low-level programming, right? This is when like the span of T memory of T stuff came out.
That's
and
right.
Kind of the big focus was to do cross-plat high performance stuff. And so from the F# perspective, we're like, hey, F# is not typically used as a high performance language, but it can be. And we want to make sure that like, if this is a foundational thing that .NET has, it works perfectly with F#. So that's what we were all about there.
Yep.
F# 4.7 in 2019 came with the ability to preview language features, which is a really, really big deal. This allowed us at the time to do development on the F# language and release it with a release preview language features with just a random compiler update, basically. And we felt that was really critical because the way the language design process works for both C# and F# is, there's a period of figuring stuff out, but you don't just ship it and say it's done, right? You sort of, you ship it in a form where you're like, hey, we got the bases covered here that we know we need to cover. But there's all these little things that we could do that are kind of more design decisions where it's kind of just about what people think, right? Like, does it feel right? And you can't figure all that out in just a room with somebody else working at Microsoft. Like, you got to get the community involved. And so you can do that by, forcing them to like compile a branch of the compiler at a particular point in time and build their own tool set and stuff like that. But like, you're not going to get that much feedback that way.
No.
Instead, if you just ship it with your compiler and then you say, hey, turn on this flag, and now you get a bunch of preview language features, tell us what you think about it. Really, really big deal. So then F# 5 landed notebook support and a bunch of other foundational features that make F#, I think, a viable competitor to Python in the analytical space. And that was kind of a big deal there. And then F# 6 released this past fall, focused on mostly simplifying syntax and semantics in certain areas, because there were a couple places in the language where a lot of beginners were like, hey, this was kind of confusing to me. And we're like, okay, you can't, there's always going to be some level of confusion when you're learning a new language. But if there's enough consistent, like people saying this part is kind of hard in particular, okay, that needs to get fixed. So that's what that was all about. And the next version of F# is kind of continuing along those lines as well, and improving a lot of the IDE experience in Visual Studio, which happened a lot over the past history, but that was kind of more performance related, and now it's kind of more ease of use related. So that was F#. Oh
We
yeah,
just got some quick support, some big shot. I'm sorry, some
yeah.
quick shout outs for an F sharp 6 feature that says inline if lambda, best addition ever. I just thought you'd want to hear
Oh yeah.
that.
That was a good one. That's a good one. So what that lets you do is, so F sharp has functions as first class entities in the language. So you can pass a function as a parameter to another function, for example, or you can
Ooh,
create a lambda and pass that thing around. Um,
wow.
the inline if lambda feature can be applied to a function type, like a parameter that's a function basically, and it's effectively a performance optimization. Beforehand, that would like create an additional object allocation in the background, and like that could basically mean that certain functional patterns were slightly less performant
Yep.
than if you wrote out some code a little bit more explicitly. I shouldn't say explicit, a little bit more non-succinctly rather.
Yeah. Yeah.
But this allows kind of like transparent, succinct programming that's a bit more in the functional style, and you take zero performance hit for doing it, which is
That's nice.
kind of aligns with simplified semantics, right?
Yep.
Right?
Yep.
You should just do something that you want to do and take no perf hit for it. So that was a great feature that landed there. So F sharp at Microsoft has been kind of interesting. So it started off in Microsoft Research in the early 2000s, kind of around the time that generics were being built. There's a whole other history with that, but now there's a fully fledged product team in the developer division focused on improving the F sharp language and tools. F sharp is a product at Microsoft. It used to be a research project, now it's a product. It's actually interesting. There's that's kind of like what Microsoft Research is for, but it's really, really hard for research projects to turn into real products at the end of the day, and so I think that's really cool that it's able to do that. Visual Studio itself is the F sharp and F sharp tools are written in F sharp, so that's something that I'll actually show. It's a really big code base.
Nice.
So if you ever are curious about, can F sharp be in a big code base and handle Visual Studio, all that kind of stuff? The answer is yes. The Q sharp compiler is the core of it's written in F sharp. There's some pieces in C sharp as well, but it's like, I think it's like 40 to 50% of their code base is in F sharp at this point. F sharp powers parts of the Bing's ad network, Azure anomaly detection services. There's a whole lot of stuff that runs in Azure in the background.
Yeah.
Part of that's written in F sharp, and then the Azure VMware solution service, which is I don't fully understand it, I'll be honest. I've looked at the code base though and helped them out with some stuff.
Yeah.
And it's a pretty large code base. I think it's for like hosted VMware solutions and kind of running on Azure, and like kind of this like management and orchestration system that powers all of that. It's written in a smattering of languages with a large core of it written in F sharp as well. And there's a lot of stories about parts of products in F sharp. Parts of products at Microsoft that are written in F sharp. There's a couple that are written completely in F sharp, but most of the time it's the products are made up of lots of different languages, and they sort of identify like a core part that needs to have like this very tight domain that can run well, but very effectively allows them to express the nature of the problems that they're solving. And F sharp is a great choice for that.
I'll hop in real quick. Two quick things for those who don't know. Q sharp, the language used for all things quantum computing at Microsoft. The second is there's a question that's come in that says, is F sharp and I'm going to say this probably incorrectly, F star are related somehow? They look similar.
Yeah, F sharp and F star are completely different languages. F star, it kind of looks similar in that it comes from the same heritage of what's called an ML style language. It is a research tool focused on allowing you to write programmatic proofs effectively. It's really cool. I encourage you to check it out. It embeds what are called refinement types into the language, which are kind of a more advanced sort of thing, but allows you to express at compile time that a particular condition will evaluate to true or false. And you embed that into the type system itself, and it allows you to write some pretty fancy stuff. What it can do is it does emit F sharp code. The tool can emit F sharp equivalent, like you write in F star, and then it translates into equivalent F sharp code that then you can write. I think it also allows you to translate into C or C++ or something like that. So yeah, it's pretty neat. I encourage you to check it out, especially if you're interested in diving deep into some more advanced language stuff that they got
Got
there.
it.
But let's talk about F Sharp outside of Microsoft, okay? Because it's used more than just there. Okay. So one of the big success stories historically, I think, is that Jet.com is this startup that was formed around like 2013 or 2014, I think. They took a bet on F Sharp to sort of power their systems. And in 2016, they got bought for $3.3 billion. That, from like a business standpoint, I think is phenomenal, because you're like, okay, we're going to, choice of language is not the primary factor. And if your business is going to be successful, I think pretty much everybody's going to agree with that.
Right.
But it does impact it to a degree, right? Like it's ultimately how your business is able to operate. Like, if the other functions of your business can deliver you the users,
Yep.
are your systems going to actually be able to handle those users?
Yep.
And to the tune of almost $3.5 billion, yeah, they can. If you use F Sharp and .NET, and they actually did it in hard mode, right? This was before .NET Core was really mature enough to take a proper bet on.
Wow.
And now it's from a technology standpoint, it's significantly better than like 2015, 2016 era. So I like to point at that and say, can your business handle $1 billion workload? Yes, it can if you use F Sharp, and I think that's fantastic. So they got purchased by Walmart, and so they're kind of the large Walmart conglomerate now. One of the big pieces of Walmart that uses F Sharp is supply chain operations for their storefronts. So the countless stores that they have all across the world, especially in the US, and operations about how stuff goes from one storefront to another. That's F Sharp code that powers that stuff, which is really cool, I think. I think due to various privacy concerns, I'm not allowed to say different bank names and stuff like that. But let's say there's a lot of large banks and speculative financial institutions and so forth that use F Sharp to power a lot of their financial modeling. Similar reasons, they identify there's kind of like a tight domain in what they're working in. They want to express that really well in the language, and then they want to tie that into a larger ecosystem of stuff that they're trying to plug into, and F Sharp fits really well there. Chowdal.com is a great example of an e-commerce website that operates primarily in Bangladesh, and also does supply chains for humanitarian efforts. Basically, you can think of it as if you're in Bangladesh and you want to do and you want ethical grocery shopping, Chowdal.com is where to go, and F Sharp is just kind of running all on the back end there for them. Imperfect Foods is another example, but that's here in the US. That they're focused on, again, sort of e-commerce and grocery delivery. It shouldn't be deliver. Their whole deal is kind of like the Blue Aprons of the world, where you kind of get your box of food that you can kind of cook with. But they're focused on food that sometimes gets thrown out because this carrot looks kind of funky or something like that. There's nothing wrong with it. It's just visually they can't display it in the store or something like that. They sort of take that and again, kind of just the whole situation. A lot of it's written in F Sharp, which is great. There's also a really cool car company for that one of the F Sharp community members, who's a longtime contributor to the compiler, actually works for, and just powers a bunch of car charging stations across Germany. And they also use Azure Functions for a lot of stuff as well. So it's not just F Sharp running in isolation, but it's working with a major framework and doing stuff. And there's just so many more. I can't possibly list all the examples of stuff success stories of F Sharp in industry, but there's a bunch. And when you get into the community and you talk with people, you can find there's all, for example, I didn't know about the Imperfect Food story until last year. And they've been using it for a while, and I'm like, oh, cool. That'd have been neat to I got Imperfect Foods once, and I didn't even realize that they were using the language that I was working on.
Now, I heard you earlier mention this, and I don't want to gloss over it. The question has just come into chat. F Sharp also runs on Azure Functions.
Yeah. Well, I mean, it's .NET, right? So .NET runs on Azure Functions.
That is amazing. So you could take those same F Sharp skills you have, whether you've been doing data processing, data analysis, or even building different types of apps, doing things behind the scenes, and go build out some Azure functions, deploy those up in the cloud. That's cool.
Yeah, it absolutely is.
Ooh, now we
Right.
get to see
So
code.
yeah, let's do a little bit of demo because I'm tired of showing these slides.
Yeah, and let me do a quick time check. Oh, I think we've got like 10 minutes. So this is gonna be like the fastest thing. God, geez.
Oh, okay. Well, that's fantastic. I can show quite a bit in 10 minutes. All right, I got VS Code open right here. I'm going to call this Corey.ipynb. Couldn't come up with a better name, so I used your name. I'm sorry.
That's fine.
So I'm going to go ahead and select the kernel here. I'm going to go .NET Interactive. It defaulted to C# here, but I'll just change that to F# because that's what we're talking about today. Let X is 12. All right, cool. What's X? 12. Hooray! That's the most exciting demo in the world. Let me just bump this up one more here.
Cool.
But you can do some more interesting stuff. Let's go values, and we'll go. That's going to be from 1 to 10.
Got it.
And we'll emit values, and there it emitted it as a chart of values here. From 1 all the way to 10. Let's go.
While you do this, do you mind just bumping it up one more time? The zoom there.
Absolutely.
There we
Okay,
go.
there we go.
Yeah.
All right, values. So let's transform these into squares, right? So we'll go, and actually we'll kind of filter them out here. We'll go list.filter fun x. This is a lambda expression. We'll go x mod 2 is not equal to 0. Okay, so that's going to give me the odd ones there. So I'm going to go back there. And let's go ahead and map them out. This is actually GitHub Copilot that I have installed here. So I'm just going to hit tab.
Oh.
And it's going to turn them into squares for me there. GitHub Copilot also works with F#, and it works inside of a notebook context, not just in a standard thing there.
I'm genuinely shocked. I'm going to say this. I'm like, my mouth just dropped. I had to like remember that I'm live on screen. Sorry.
Yeah. It's when you get used to it, it's just kind of like second nature using it. That's why I'm being a little nonchalant about it, but it's really, really cool. Copilot kind of gets better the more that you do stuff. So let's say I want to just delete this. I'll just kind of do this. I'll go I'll declare a function here. Is odd x is going to be x mod 2 is not equal to 0. And then I'll declare another function. So you notice in the syntax here, there's the keyword let. Mm-hmm. So the name of the function is odd. It's a parameter called x. You notice that I didn't give it a type. I didn't say that it's an int, but I hover over it and it says that it's an int.
Oh wow!
Kind of cool, isn't it?
Look at that type inference
right there.
Yeah.
This is why like people who like Python code will find that they like F# because like I'm just typing and writing, like I'm not having to do the boilerplate stuff, right? I could do that if I really wanted to. I could give it a type declaration. I could even declare the entire thing, right? So that this explicitly says that that's going to be an int, and then that's actually going to fail to compile because it says, hey, you said that this whole function is going to return an integer, but you're actually returning a bool.
That's right.
So you got to do that, but like I don't have to do any of that.
Yeah,
it's pretty great.
This is so cool to me.
So then I'm going to square stuff, and then I'm going to go values, and we'll go list.filter is odd. Okay, so this is the functions as first class values thing that I talked about, right? I have a function here called is odd, and I'm passing it as a parameter to the list that I'm filtering, and then I'll let Copilot fill in the rest for me. It was able to identify that I have a function called square, and I'm just going to pass that over there, and I get the same thing. This is interactive programming. And it's great if you're learning the language, and it's really great if you're futzing around with some data, I think.
I mean, this is super fast. It's super succinct. It's very direct. I want to go play with F# now. I'm going to be really honest.
Well, I'm gonna blow your mind even more. Okay, so I'm gonna pull in 2 packages. Plotly.net.interactive. So Plotly is the most popular JavaScript charting library in the world. And it has .NET bindings. They're written in F#, by the way. and I'm pulling in a library called fsharp.data. This pulls in what are called type providers that allows you to get IntelliSense for your types.
Got it.
So, all right, I'm going to open up some stuff there, and I've written this code because I don't want to bore you with writing all of this necessarily myself.
Yep.
But so here I'm going to create some values. I'm going to create an X series, a Y series, an upper bound, and a lower bound. And
Okay.
you notice in this code here, I have this thing called data.rows. If I hover over, I get a thing called time. Well, where did time come from?
Yes.
Right? Where did that come from? That's kind of weird. That doesn't seem like. The answer is it actually came from the data itself, right?
Wait,
so
what?
I get this it's strongly typed. And so I get right here this raw GitHub user content, wind speed, Laurel, stuff like that.
Mm-hmm.
I'm going to open this up in the browser here. See this header right here that says time in the CSV?
Yeah.
There's this other one, 10-minute standard deviation, time, 10-minute sampled average.
Yeah.
Right there. That's where it's coming from. So what's actually going on here is this thing called this CSV provider coming from the fsharp.data package is reading that CSV and generating IntelliSense with the F# compiler and basically saying, hey, there's this column called time. I'm going to make that a real thing. And then you can get IntelliSense for it. So you notice I have these like double tick 10-minute sampled average, 10-minute standard deviation. Again, that's coming from that data, and it's being fed into the compiler, and the compiler is generating types that you can then use.
I am legit. Okay, so I'm sitting here blown away. My friend Luce Carter, welcome Luce, says F# always makes me smile. I should write it more often. I feel the same way because I can't stop smiling. My face is starting to hurt.
All right. So you're going to smile a little more because I'm going to generate a nice fancy graph that like every Python data analyst should also be able to generate in their own code. Boom, right there. Okay.
What?
So I've charted measurements. This is wind speed in this lovely state of Nebraska, cornfields and all. I've been in Nebraska. I can say that. I have family that's near Nebraska, and it's all cornfields. It's fine. And so this is using plotly.net. And, again, like this is actually in their documentation. This is an example of doing some advanced charting in Python. And all I did was recreate the chart in F# actually using kind of, generating some stuff. So like this is a non-trivial thing.
Right.
I'm not just doing a simple line chart, generating like a sine wave or something like that.
Right.
I'm layering different measurements onto the same chart and doing some like subplotting and that kind of stuff, generating like a nice table and that kind of stuff. And then I can even, for my business, if I wanted to, I could download this plot as a picture and then, save it, that kind of stuff. So, you can use that chart for this, which is amazing.
I'm like, well, even the code, like when we looked at the code, I know you said it's non-trivial, but as a .NET developer, I can very simply follow along with what's happening. The XY trace says, let's do a scatter plot where for each X and Y, we'll then initialize the scatter plot, set some trace info information, set some lining information for how this thing is supposed to be displayed, and do the same thing for the markers. This is really easy to follow along with. I'm blown away.
Yeah, and this is, this pipeline operator here, this is what you use all the time in F# code. All this does is it says, hey, this right here generated some data.
Yep.
We're now going to pipe it into a function that's going to output something else. That output is going to be the input to this guy. That output's going to be the input here, and so forth. And then you end up with this thing called this XY trace. Which is a trace 2D is the type in plotly.net.
Right.
And that's just it, right? I'm not trying to be too excited about it because like this is just everyday F# programming, right?
Yeah.
Like this isn't the magic that I'm showing, and all the other F# code sucks or something like that.
I'm excited about it. I won't even lie. I am blown away.
So in a limited amount of time, I'm going to open up the F# code base in Visual Studio. Okay, so we got 69 projects. It's quite a lot there. This is the compiler library, which is enormous.
Yeah.
Won't go there. Instead, I'm going to go over to this fsharp.editor thing, and here's what I'm going to do. Okay, so I'm going to create an F# script file, which is kind of like another interactive sort of thing that you can do there. And we'll go let function stuff is equal to 12. All right, so this is just a function that when you call it says 12, right? Simplest thing ever. All right, and then we're going to want to print that out. And we'll go function stuff, call it. Okay. There's an error.
What's the
Why
error?
is there an error? Well, actually, because this right here, let's say I put a space here. This is actually considered valid F# code, right? That this is like a unit thing, right? This can trip up some beginners sometimes. The unit type, and so like, oh well, how do I fix this?
Yeah.
Right. Well, we got a quick fixer. Wrap it in parentheses. Kind of deal with that right there. Okay. So this is basically saying, hey, we have an error. I bring this up because this is a common case that some beginners can run into sometimes, and we're just going to wrap it in parentheses so you get the tooling. Just kind of helps you along there. So I'm going to go to code that actually does this. Okay. So this should be the wrap expression in parentheses code fixer. Okay. So we got here. I should be able to build it here. I'm actually just going to do it multiple ones here. I'm going to go ahead and build a new instance of Visual Studio that's going to have this different code fixer in here. So what's going on is I'm inside of this project called f#.editor, which is a big, it's another big project inside of the code base that has all the Visual Studio tooling baked into it.
There's a lot of fun.
And then I'm going to see if I can build the entire compiler, which is an enormous project. I'm going to build the F# tools in Visual Studio itself, and then I'm going to have that launch a new instance of Visual Studio that's going to have a change where, before you could see that it wrapped it in parentheses. It's going to wrap it in 2 parentheses instead because we're being silly like that. Right. So you see right here, I got this Visual Studio 2022 box right here.
Right.
This is not the Visual Studio that I was just working in. This is a brand new instance of Visual Studio that I just created with this code base. So now I'm going to go inside of here, and you'll notice the reason why it's different is, see, the version numbers are all actually I think they changed a few things around here since the last time I was in here. It's kind of hard to see, but you see this preview thing.
I see the button up there in the top corner,
as it's called there. That's actually the F# uses some Roslyn tooling to build some stuff in the background of the Visual Studio side. So this is an instance of Visual Studio that I just built myself. I'm going to go to the script file that I just created. I'm going to copy paste. I'm going to bring this over. Okay. And we're going to generate that same error. Wrap expression in parentheses. It's going to put 2 parentheses in there. Okay. So if you're curious if F# can be used in Visual Studio in a big project, integrating with a big environment like the Visual Studio system itself to do stuff, the answer is yes. And that was I compiled pretty much this entire code base in the course of while I was just talking.
Right.
There wasn't too much. It was like maybe a minute or so. And I have a new version of the F# tools built in here that has my changes baked into Visual Studio.
Oh man, I gotta tell you, I'm like, my mouth is, I have to close my mouth because I'm kind of crazy with the way I'm reacting here. We got a great question here in chat because I'm blown away. Let me just make sure we get this question answered. We've got just 2 minutes left. It says, can we write custom F# analyzers with fixers and distribute them via NuGet just like you can with Roslyn analyzers?
Somewhat. There is an SDK called the F# Analyzers SDK that kind of lets you do that. It's not as sophisticated as a system as Roslyn analyzers. And because of that, one of the major initiatives that might be happening in the next version of the F# language, fingers crossed because I really hope it does, is that an analyzer system just like for Roslyn gets built so that you can have kind of like a pluggable analyzer thing that you can do, right? Because like today, you have to take a dependency on actually the F# compiler services itself, and there's a bunch of stuff in here. I won't dig into it too much, but like a lot of the APIs that you would use for that equivalent kind of stuff exists here. But it's mostly built for supporting F# editor tooling like you see in Visual Studio or Visual Studio Code or JetBrains Writer, and it wasn't built in mind for general purpose analyzers that you could then distribute and NuGet the way that you can with Roslyn today. That is something that is on the roadmap, and I believe there's even a design for it. But just because something is on the roadmap doesn't mean it's like actually going to ship at a given time. But this is something that I know that the team identified as being really critical for the future of the language. And so not yet, kind of today. It's a little more complicated than we would like today. In the future, it will be a lot better, I think.
Well, I got to tell you, Philip, we are just at time. Let me just ask the one final question before
Okay.
we transition out of here, which is like, what's the one big thing we can do? Like, I've just seen some amazing things. Folks who are watching across the different platforms have seen some of the amazing things we can do with F#. What's the next step? How do we go play around with it?
Indeed. Okay, so there's a couple easy ways to get started. Okay, if you're working and you have a need for a small tool, right? You got to like, I don't know, something in your system is like some kind of data format that needs to get parsed out into something else or something like that, or convert this, convert one thing into another, or talk to these endpoints or something like that. Write it in F#. If it's something that's going to take you a couple days to do anyways, and it's not really that big a deal if it fails.
Right.
Write out an F#, use it as a way to use the language, especially if you know what you're trying to do. If you have a need for more tests, which I'm sure most developers probably do, you can create a Visual Studio test project and test your C# code and F# code. That's a good example of how you can, integrate with an existing code base and maybe write a couple helpers to like transform data and that kind of stuff, kind of get your feet wet a little bit. If you know that you have a pretty hefty domain that you're operating in, consider using F# to model it. There's a book called Domain Modeling Made Functional. Domain Modeling Made Functional is the name of the book. It's really popular in the community, and a lot of C# developers have picked it up actually because it's so good at the domain modeling side of things. And it uses F# as the example language because it's so easy to do that kind of more complicated domain modeling you might need. And then just in general, if you want to learn something new and you're just always curious about building something that you've never done before, try doing it with F#. Like build a DSL, like I mentioned, right? If there's like a binding to a library or a tool or a platform or an environment or like anything, you're like, oh gosh, it'd be nice if I could access this from .NET. Try using F#. And you might run into some rough spots, but whenever you run into rough spots, that's when you actually learn things. And so, I think there's a lot of easy ways to get started where, you don't have to just go in and rewrite your whole code base. That's what I would recommend. And then from there, like you can connect with the community and learn even more and do a lot of things from there. So the easiest way to get started is you just go to this link, ake.ms/F#home. This is the Microsoft's homepage for F#. It's got, like some slick code samples, some examples of how you can use F#, and, links to go and download the right stuff and make sure that you're set on the right path to get going. So,
my goodness, Philip, thank you. I got to tell you, I'm blown away. I'm ready to go play around and actually go test my C# with F# because folks who've watched me write code live know that I do not like to write tests. So we're going to change the narrative, change the paradigm shift. For our friends who are watching, please just give a big thank you to Philip for this amazing session.